Section 8.11 Complex Numbers, Part 3. Number 5. I want to remind you that our goal is to write our expressions in the form a plus bi. So how are we going to write 6 plus 4i divided by I in the form a plus bi if we have an I in the denominator? Well, we can multiply it by something. What do you think we can multiply I by to make it a real number? If you said multiply by I, you're correct, because I times I is I squared, which equals 1. Let's go ahead and do that now. But whatever we do to the bottom, we also have to do to the top. Then let's distribute that I. We get 6i plus 4i squared. And on the bottom, we get I squared. And now I'm going to replace all my I squares with -1. And then we're going to simplify this a little bit more. Now we still don't want that -1 in the bottom. So what I'm actually going to do is I'm going to split this fraction. And then I get -6i if I simplify plus 4. Now, although this is the correct answer, I do want it in the form a plus bi where the real part is first. So I'm just going to rearrange the 4 and the -6i. Okay, next. Remember I said that the conjugate is going to become very important in the next questions? Well, let's go back to what the conjugate was. So here's an example of the conjugate where you have two factors that are exactly the same except for the signs. One's positive and one is negative. And then I said if we multiply those, because one's positive and one's negative, your middle terms are always going to cancel and you're actually going to end up with a real number. We're going to use that fact in example 6. We're going to multiply by the conjugate of 2i, which is 2 plus I. And then again, whatever you do to the bottom, you also do to the top. Sorry, my plus signs are a little bit messy. And now we have to FOIL. So we have on top first times first, 3 times 2 is 6. Outer times outer, 3 times I is 3i. Inner times inner, 4i times 2 is 8i. And last times last, 4i times I is 4i squared. And then on the bottom, we have first times first, 4, outer times outer, 2i, inner times inner, 2i, and last times last is I squared. Now in the future, you're going to see that I don't even do the middle terms because they're always going to cancel. And I actually only do the first times first and last times last. And we want them to cancel because we don't want an I in the bottom, which is why we always use the conjugate. Okay, let's go ahead and combine like terms. We have 6 plus 11i plus 4, and then that I squared turns into -1. And then on the bottom, we have 4 minus -1. Let's go ahead and simplify that. So this 4 times -1 becomes -4. So I'm going to go ahead and do 6 minus 4, and that's 2 plus 11i. And then on the bottom, we get negative times negative, which is a positive. So that's 4 plus 1 is 5. Now, we're going to do the same thing we did in the previous example where we split the fraction so that it looks like a plus bi. Since we can't reduce the fractions, that's our final answer. We're going to leave that like that. Okay, next we have square root of -9 plus 3 squared -16. Before I can even simplify square roots or add them, we need to simplify them. Let's go ahead and do square root of -9. when we're in the real plane, you can't do this. It's not possible. But because we're in the complex plane, it's possible. Square root of 9 is 3. And the square root of -1 is I. So square root of -9 is 3I. Plus 3 and square root of -16 is 4I. And we can just go ahead and simplify that now. And notice that in this case, we don't have a real part. We only have an imaginary part. Let's end our video there and join me again for part 3.